Let's read 9th standard ICSE Physics 7C sums, the mirror formula. While doing physics sums of 7C, we need to remember the sign conventions, which is similar to the sign conventions in math graph. So if we imagine the pole of the concave or convex mirror as the origin, and the principal axis is the x-axis, and the perpendicular at the pole as the y-axis, then we know that the right hand side here is positive, whereas the left hand side is negative. Similarly, above the x-axis this is positive and below is negative. Same sign conventions apply for concave mirror as well as convex mirror. Now there are three formulae we need to remember. The focal length is half of the radius of curvature. 1 upon f is equal to 1 upon u plus 1 upon v. Now this formula is for mirrors only, not for lenses. And also magnification, which is the ratio of the length of image upon length of object, which is also equal to minus v upon u, whereas v is the distance of the image from the pole and u is the distance of the object from the pole. Whenever we do a sum, we should try to imagine the diagram relevant for that sum. Usually for any concave mirror diagram, you will notice that u is negative. Of course, u, that is the object distance from the pole, is always negative because we always keep object on the left hand side of the mirror, be it concave or convex. There is no exception to this. V, that is the image distance from the mirror, is also negative if it is a real image, because the image is being formed on the left hand side of the mirror, or rather in front of the mirror. So whenever we have a real image, V has to be negative because it will be inverted. So most of the diagrams in concave mirror will have V negative. Only in one case is V positive, that is the image is behind the mirror because it's a virtual image. Do you remember which diagram is that? The last case of a concave mirror, when the object is between F and P. That's the only case when V is positive because image is formed behind the mirror. Here, in fact, the image is magnified as well and erect. As far as convex mirror is concerned, V has to be positive always. It is not possible that any numerical for a convex mirror you will get a negative V, because real images are impossible to be formed by a convex mirror. Let's talk about image height and object height. Image height has to be positive, of course. Sorry, the object height and image height will be positive in case of convex mirror. They can never be negative in case of convex mirror. For a concave mirror, usually object height is always positive, but image height is negative because it is below the principal axis or the x-axis. Only in this last case of virtual image do we have the image height positive. So remember, if the image height is positive, it's a virtual image. And finally, magnification. Magnification has two pieces of information in its value. One is the positive or negative sign and one is the number, the magnitude. The positive or negative sign simply tells us if it's a real image or a virtual image. If it's a virtual image, then magnification will be positive, that is erect image. And if the magnification M value is negative, it means it's a real image, that is it will be inverted. Secondly, the value, the number, if it is greater than 1, it is magnified. So if the magnification is 3, it means the image is 3 times the object. If the magnification is 1, it means the object and image are of same size, which is this case. Only this case has it. Whereas if the magnification is less than 1, let's say 0.5, it means that it is diminished image. So in case of convex mirror, magnification is always less than 1. Let's say 0.5, 0.9, which means that the image, 0.9 means image is 0.9 centimeters if the object is 1 centimeter long. But note that here it will be plus 0.9, whereas here it could be minus 0.9. The minus sign simply means it is inverted. Here, the magnification is -2. -2, is it magnified or diminished? It's magnified because 2 is greater than 1. So this is twice the size of the object. The minus sign simply means that it is real, that is inverted. So a good way to remember these signs is through this chart. So if you remember these signs, you won't make silly mistakes in the numericals and you will score very well. Sums are very easy, but the sign mistakes rob us of all the marks. Now let's start with the second sum. The focal length of a concave mirror is 10 centimeters. Find the radius of curvature. Now we know that radius of curvature is twice the focal length in any mirror. But we have to be careful about the signs. Remember, for concave mirror, the focus is on the left hand side, so it will always be negative. The focal length will be negative. For a convex mirror, the focus is always on the right hand side, so f will always be positive. So f is equal to minus 10 centimeters. The minus sign simply means it is on the left hand side. That is, it is a real focus, whereas a convex mirror has a virtual focus. Radius of curvature is twice of it, so we are getting a negative answer. But remember, in any numerical, we will never leave the answer with negative sign, especially with a number. Rather, we will write the positive answer and we will explain what was this negative sign all about. So here I will simply say it's a concave mirror, or you can say it's a real focus. This has to be done. Now in the fourth sum, an object is placed at 4 centimeters distance in front of a concave mirror. Object distance is always negative, so u is equal to -4. Always write the data first. Concave mirror means the radius of curvature has to be negative, so capital R is -24. From that I can get f, which will be -12, half of this. Find the position of the image, that is v is equal to question mark. And is it magnified? Well, I can find m and find the answer. So writing the data, u is equal to -4, r is equal to -24, v is equal to question mark. First of all, focal length, -12 centimeters. If you forget the minus sign, the whole sum will go wrong. Formula, you have to write it in every sum. Substitute the values, -12 out here, -4 out here. So the only unknown variable is v. Now be careful while solving with fractions, especially when you have to find the LCM and there is a negative sign. First of all, the minus goes up, and when it shifts to the left hand side, it becomes positive. So it becomes -1 upon 12 plus 1 upon 4. LCM is 12, so into 3. That way we can bring the denominators together, so it becomes 12 minus 1 plus 3. So that's 2 upon 12, 1 upon 6. But that's the answer of 1 upon 3. Do not forget to do reciprocal of that final answer. So v is 6 centimeters. It's a positive answer, not a negative answer. What does that mean? It means it is formed behind the mirror. If it was negative sign, then we would have written is equal to 6 centimeters on the next line, and we would have written in brackets in front of the mirror. It is compulsory to mention this because they have asked for the position of the image. So we shouldn't just give the numerical value, but also the description of it. Now, even before I solve ahead, I know that this will be a magnified image because in concave mirror, there is only one case where the image is behind the mirror, which is the last case, the virtual image is formed, and you know that it is a magnified image. So that's why I say that always in every sum, imagine the diagram which is relevant to that sum. This way you will not make any silly mistake and you will be able to find answers even before solving, so that you can cross check your answer later. Anyway, I am going to solve ahead. So m is equal to -v upon u. So v was 6, u is -4, minus gets cut, 1.5. It's greater than 1, so it is magnified. By the way, it's positives, not negative. That means it is erect, but that was not asked. Sixth sum. An object which is 5 centimeters high is placed at a distance of 60 centimeters in front of a concave mirror. 5 centimeters high, so O is +5, that is object height. U is -60, F is -10. I have to find V and I. So write the data first. Now I'm going to use this formula. Substitute -10 here, -60 here. That becomes +1 upon 60. LCM, of course. Be careful while solving. Don't just copy. Do the fraction solving on your own. You need practice in that. It won't take much time. And don't forget to reciprocate in the end. Here we got a negative answer, so we have to mention in front of the mirror. Next, they want I. We know the formula of M is I upon O, which is also -V upon U. Here I know the value of O, V, I just got it. By the way, the minus sign was as it is, and v is minus 12. So minus minus will become plus. U is minus 60, 1 minus remains. So the answer I'm getting is minus 1 centimeters. Negative sign simply means that it is inverted, so it has to be mentioned because we can't leave the answer with a negative sign. Next, the eighth sum. When an object of height 1 centimeter is kept at a distance of 4 centimeters from a concave mirror, so O is plus 1, U is minus 4. Its erect image, I know this is the last case of concave mirror because only there we have an erect image. So it will be magnified for sure. It will be behind the mirror for sure. See, even before solving the sum, I got so much information, which makes it easier for me to solve ahead. Its erect image of height 1.5 centimeters. See, it is magnified indeed. Is formed at a distance of 6 centimeters behind the mirror. So V is equal to plus 6. Find the focal length. That's it. They just want the F. Then why did they give us I and O? Perhaps just to confuse us. So just write the formula, substitute the values, and get the value of F, which is a real focus. So I remove the negative sign in the end. 10th sum. A concave mirror forms a real image of an object placed in front of it at a distance of 30 centimeters. That means U is minus 30. And size 3 times the size of the object. So magnification will be 3. But plus 3 or minus 3. Be very careful with the sign. If you forget the correct sign, then you won't get the right answer. Concave mirror forms a real image. Real image means inverted image. Inverted image means magnification has to be negative. So M is indeed minus 3. They want V. That's easy. M is equal to minus V upon U. You substitute the values, cross multiply, and get the value of V. It is indeed in front of the mirror. It's a real image. They've also asked you to find F. Use this formula, substitute the values. Be careful with the signs. The minus sign goes up. The minus sign goes up. LCM into 3 into 3. So minus 3 minus 1 upon common denominator 90. That's minus 4 upon 90. Don't forget to reciprocate it. And I'm getting 22.5 centimeters. It's a real image, so real focus. The 12th sum. The image formed by a convex mirror. Convex mirror. So give me some details. Image will be diminished. Image will be formed behind the mirror. Focal length is positive. What else? The size is 1/3 the size of the object. So magnification is 1/3. Magnification is 1/3. So will it be positive or negative? It will be positive because it's always erect and virtual for a convex mirror. So substitute those values, and M formula is minus V upon U. If I cross multiply, I get this answer. And that's what they wanted. They wanted a relationship between U and V. It's a negative relationship, which should be avoided in life. 14th sum. The magnification for a mirror is minus 3. Okay, magnification is minus 3. Minus means it is inverted and magnified. It has to be a concave mirror. They've not asked for it, but you should be able to interpret all these things. So before you do the remaining sums and the SCs on your own, don't even look at the answer. Try to interpret as much data as you can and imagine the diagram. Then you'll become an expert in these numericals. So how are U and V related? Same method, substitute the formula, minus sign gets cancelled. They have a positive relationship and they live happily ever after. Hi students, this is AJ sir. If you like this video, press the like button. If you would like to enroll for my online test series or online lectures, email me or message me on Instagram. Check the description for more information.